I calculate using Faraday's law. So I calculate the dN over dt. And then I estimate how long does it take for you to finish one experiment. Okay, now imagine if you want to conduct the experiment longer, that means we need to store more what? Hydrogen. Why? Last longer. So what is the implication of storing more hydrogen? Remember, if we store more hydrogen, gas pressure will increase. What else? Gas pressure will increase. The implication of this increase in pressure, if the pressure is higher, that means what? In terms of safety, if the pressure is higher, right? Then
the tank must be stronger.
Must be not stronger, thicker. Correct. So if you want to use a thicker tank, the implication of this cost, right? Cost. The most important thing is cost. So it will become more expensive. Yes. So now I'll show you this one. Also, yeah, hydrogen is correct in terms of weight. So imagine if I store more hydrogen in this fuel cell car. Maybe I'll just on the floor. I'll show you. Okay, guys, let's see whether this fuel cell car can run or not. So what's the implication if we store more hydrogen? It will run slower, right? Because more weight. What else? The tank is bigger. The tank is bigger. So in terms of cost. Okay, so this will help you on the design of your fuel cell application. So you need to estimate how big the storage you need. How big, the storage for the hydrogen if you are using the hydrogen fuel cell. Because for this one, the storage is very small. Okay. So this one, that means this fuel cell car can only run for a short time, right? Okay, so you need to think about this when you design the fuel cell application for your project.
That's how we know about the atmosphere pressure.
You just choose randomly. Let's say you choose 5 atm. If you choose 5 atm, that means it's quite high, right? Quite high, then you have to use a thicker tank. So the cost may be more expensive. And then in terms of weight also, if it is bigger, okay, then we will continue with the next question, then you will understand more. Okay, now question 3. We attempt question, not question 3, question 4. Okay, this one will become very handy for your. They already sell this in US. So the fuel cell run using the iPod Nano, not iPod Nano, it's a MP3 player running using methanol fuel cell. Okay? So now you attempt this question. What's the difference between this question and the previous question? Yes, this question is using direct methanol fuel cell. So you write down the direct methanol fuel cell reaction first. Okay, we attempt question 4. Question 4 using direct methanol fuel cell. So what is the reaction? The oxidation reaction. Remember, the oxidation reaction is we have one methanol plus how many hydrogen? How many water? Okay, you need to remember how to get the oxidation, right? Using overall and the reduction. You have to practice how to get this. Okay, so now we know that the N is 6. The N is 6. Okay. So what else is known in the question? Current produced is 0.58 ampere. Okay, we write down I is 0.58 ampere or 0.58 coulomb per second. Then the amount of methanol stored in the iPod is 100 milliliter or 5 mole per liter like this. Okay, we will go to that later. Now we already know the I. We already know the I, we know the N. So we need to calculate the dN over dt. I equals to N F so the dN over dt is I over NF. The I is 0.58. The N is 6. The F is 96,500 coulomb per mole. Okay, now we balance the unit. So what's the result? One times minus 6 mole per second. Okay, so what does this mean? Same case as hydrogen. This means what? Every 1 second. Every 1 second. 1 times 10 to the power minus 6 mole of methanol. Okay. Remember, we always talk about the fuel. Either it's methanol or hydrogen. Okay. So this means every 1 second, 1 times 10 to the power minus 6 mole of methanol is consumed. Okay? We know every 1 second there will be this amount of methanol consumed. Okay, and then from the question we know the iPod store 100 milliliter of 5 mole per liter methanol solution. Okay, so what does this mean? Yes, correct. So we know that, okay, firstly guys, the concentration of methanol is 5 mole per liter. Okay. It's known here from the question. 5 mole per liter methanol solution. The concentration is 5 mole per liter. That means every 1 liter of solution we have 5 mole ethanol, 5 mole methanol. Okay, but the amount of solution that we have is 100 milliliters. So that means how many methanol are inside? So in 100 milliliter, we have 0.5 mole. Okay, now imagine this is the imagine this one is the methanol storage. Inside this methanol storage we have 0.5 mole. Okay, and then we know the consumption is 1 times 10 to the power minus 6